Alright, so in this video, I'm going to solve the equation 2 to the power of x is equal to x to the power of 32. So, to solve this, I'm going to first start by taking the power of 1 over x on both sides. So I get 2 to the power of x to the power of 1 over x is equal to x to the power of 32 to the power of 1 over x. And the reason I did this is because if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So x and 1 over x, these two cancel out. So on my left-hand side, I just have 2. And for my right-hand side, 32 and 1 over x multiply to get 32 over x. Now, from here, I'm going to take the power of 1 over 32 on both sides. And if you guessed, we're doing this to get rid of this 32 on my right-hand side. So for my left-hand side, I just have 2 to the power of 1 over 32. Now for my right-hand side, these two are going to cancel out. So I get x to the power of 1 over x. That's all that's there remaining. And now, we want to simplify this because our end goal is to make this in the form a to the power of 1 over a is equal to b to the power of 1 over b. So in that case, if that's in the form, that means a is equal to b. So we already have x to the power of 1 over x over here. So we just need to make the left-hand side be in the form a to the power of 1 over a, meaning this number here has to equal this number. So we need to find a way to make that. Well, what we can do is rewrite 1 over 32 as 2 over 64. And now, remember, this is the same thing as if I have something in the form a to the power of n to the power of m, this is equal to a to the power of m times m. So I can reverse this and rewrite this as 2 to the power of 2 to the power of 1 over 64. And 2 to the power of 2 is 4, so I get 4 to the power of 1 over 64 is equal to x to the power of 1 over x. Now, this still isn't, these two numbers still aren't the same. So what we're going to do is repeat the process once again. 1 over 64 is the same thing as 2 over 128. And I can rewrite this as 4 squared to the power of 1 over 128. Now 4 squared is 16, so I get 16 to the power of 1 over 128 is equal to x to the power of 1 over x. And they still aren't the same, so I'm going to repeat it once again. So I get 16 to the power of 2 over 256 is equal to x to the power of 1 over x. Now this is the same thing as 16 squared to the power of 1 over 256 is equal to x to the power of 1 over x. And now 16 squared is equal to 256. So I get 256 to the power of 1 over 256 is equal to x to the power of 1 over x. And now notice that these numbers are the same, and this is in the form, as I said, a to the power of 1 over a is equal to b to the power of 1 over b, meaning a is equal to b, so x is equal to 256. So this is my solution to this equation. If you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family. Alright, so in this problem, I have 2 to the power of x is equal to 3 to the power of x. So I obviously want to find the value of x here. So for my solution, I'm going to first start by writing 2 to the power of x is equal to 3 to the power of x. And I'm going to take the log of base 2 on both sides. So now I have log base 2 of 2 to the power of x is equal to log base 2 of 3 to the power of x. Now, if I have something in the form log base a of a, this is simply equal to 1. So as you see here, we have log base 2 of 2. And actually before I cancel these two out, if I have something in the form log base a of to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have x as my exponent, so I can move this to the front. So now I have x times log base 2 of 2 is equal to, I'm going to do the same thing over here, log base 2 of 3 to the power of x. I can move x to the front here. So now I have this is equal to x times log base 2 of 3. Now remember, if I have something in the form log base a of a, this is equal to 1. So log base 2 of 2, these two cancel out, so I get simply left with x times 1 is equal to x times log base 2 of 3. And x times 1 is simply x, so I get x is equal to x times log base 2 of 3. Now, I'm going to subtract both sides by x log base 2 of 3. So these two cancel out. I get x minus x times log base 2 of 3 is equal to 0. Now if I factor out x, I get x times 1 minus log base 2 of 3 is equal to 0. And if I divide both sides by 1 minus log base 2 of 3, these two cancel out, and I'm left with x is equal to 0. Alright, so in this problem, I have a to the power of 3 plus a squared equals 36. So to actually find all solutions to this problem, I need to first start by finding one solution. So to do that, I'm just going to plug in some numbers and see if they work. So let's try 1. If we plug in 1, we get 2 is equal to 36, which is wrong. If we plug in 2, we get 8 plus 4, which is 12 equals 36, which is wrong. If we plug in 3, we get 3 to the power of 3, which is 27. 27 plus 3 squared is 9. 36 equals 36. So a equals 3. This is one solution of a. And now that we found one solution of a, we can use this later. So we can use this by making a to the power of 3 plus a squared equal 3 to the power of 3 plus 3 squared, because we know that a equals 3. So I'm just plugging in 3 and making them equal to each other. So now I'm going to subtract 3 to the power of 3 plus 3 squared on both sides. So these two cancel out. I get a to the power of 3 plus a squared minus 3 to the power of 3 plus 3 squared minus 3 squared, is equal to 0. Now I can rewrite this to be in the form a minus 3 times a squared plus 3 squared plus (3a) plus a plus 3 is equal to 0. And this simplifies to a minus 3 times a squared plus 12 plus 49, plus 4a is equal to 0. So now this gives me two equations. I have a minus 3 is equal to 0, and I have a squared plus 4a plus 12 is equal to 0. So for a minus 3 equals 0, a obviously equals 3, so this is one solution of a. And for a squared plus 4a plus 12 equals 0, you have to use the quadratic formula to solve this, and I'm not going to waste your time by doing that. But if you do end up using it, you get that there is no solution because you get the square root of a negative number. So now that we know that a equals 3, remember how this is actually going to be our only solution because this doesn't work. So a equals 3 is our only solution. Alright, so in this problem, I have a to the power of x is equal to 80. So to solve this, I'm going to first rewrite 80 here as 8 times 10. So now I have a to the power of x is equal to 8 times 10. And now I'm going to divide both sides by 8. So now I have a to the power of x over 8 is equal to 10. So if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over a to the power of 1, that's going to equal a to the power of x minus 1, which is equal to 10. Now 8 here is the same thing as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x minus 1 is equal to 10. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1, that's going to equal 2 to the power of 3 times x minus 1, which is equal to 10. And I can distribute the 3, so I get 2 to the power of 3x minus 3 is equal to 10. Now I'm going to take the log on both sides, so I get log 2 to the power of 3x minus 3 is equal to log 10, and log 10 is equal to 1. So I get 1 is equal to 3x minus 3 times log 2, because I can move this to the front. And now if I divide both sides by log 2, these two cancel out, and I get 3x minus 3 is equal to 1 over log 2. And now I can add 3 on both sides. So I get 3x is equal to 1 over log 2 plus 3. And if I divide both sides by 3, I get x is equal to 1 over 3 log 2 plus 1.